Okay, our next speaker, James Hileman and Miranda Muse. You know, I was just at their place, was it last Sunday? I was impressed my first time there. All these greenhouses and especially if you're a vegetarian, plenty of fresh vegetables. My wife bought a whole bunch over there. By the way, vegetarian is an Apache word for poor hunter. James Hileman and Miranda Muse are Portal, Arizona locals with the Wind Dancer Farms LLC. They'll be giving us a peek into their lives of running a farm, their hybrid Earthship build, and future goals for the property. Wind Dancer Farms is located in Portal, Arizona. Please welcome James and Miranda. You're going to do the chocolate?
She wants to.
Well, her name is on here too.
Oh, I love it. Right. And where's our pointer at? It's got a laser pointer, right?
It's got a laser pointer.
Where's the button for it? I think it's that one right there.
Back, forward and back.
Where's the laser?
Uh-oh.
Did it start it? Okay, hit pause.
The general comes.
Okay, well, we'll figure out the laser. Thank you, everybody. You can. You got it? Pause.
We don't call it
Ready?
house, we call it a vessel. And it is a vessel that will. Exist on.
Well, I can see this is gonna work pretty well.
Counter the phenomenon of this earth.
Well,
there are many phenomena of this earth to provide sustenance for people. And if we don't do this, then we are dependent on infrastructure. Infrastructure is very scary and very dangerous and very mismanaged. And the goals of infrastructure are more about power and money than they are sustenance of people. So we have now taken this into our own hands to create.
Smaller, Mike.
Sustenance of people. We distilled it down to what is the minimum number of things that people need for just life. Existence, not in beyond that. So we have come up over the years with 6 things. That is, people need comfortable shelter. The Earthship. It must be and cool. It's hot outside without fossil fuel. So we encounter the physics of the planet to do this. And they design the building. It has nothing to do with architectural work. Things or anything else. They need water. Water is reusable. Mexico, here in Taos, we 7 inches of water per year, and that's not enough. If we take that water and put a shower in it, and then we recapture that shower water and run it through botanical cells, which are rubber lined planters in the hallway that grow plants and food, which then in turn clean out that water with their roots spitting out oxygen. We capture the water again and flush the toilet with it. And then we take the toilet water out to an anaerobic processor and into rubber lined cells to do landscape. So that's comfortable show. That's water and that's zero discharge sewage treatment, all relating to each other. And then there's electricity, and everybody knows about wind produced electricity and solar produced electricity. But one thing to point out about Earthship is because they do so many things for themselves, they need less electricity. Since an Earthship heats itself, it doesn't need electricity to be involved in heating. Since an Earthship provides its own water, it doesn't need electricity to pump a well. So an Earthship, by definition, needs less electricity, and we get that electricity easily from the sun and the wind. And we need something to do with what we call garbage. We invented garbage. It didn't exist before humanity. So we need to figure out how to use our garbage. And there's a lot of things being attempted, but nothing really that's successful. So we're just trying to make these vessels consume garbage in their construction in place of a lot of manufactured materials. And as we keep doing this, we find out that that the things we call garbage, tires, cans, bottles, cardboard, some of these things are manufactured better than the materials that are manufactured for construction, which in many cases are garbage themselves. So we've taken these 6 things and addressed them in a building that we call, it's a vessel that we call the Earthship. And that is the definition of and rationale for this thing, this vessel that we call Earthship.
I started that a little early, sorry. Thanks for coming, everyone. This is a fun time, and big shout out to Penny and everyone involved putting together. So what I wanted to do here was let everybody see this video by Mike Reynolds. He's the one that coined the phrase Earthship. He's the one that designed and built the first one in 1971, which is still standing today and still functional today. And he has Airbnbs. You can take a trip to Taos and rent one for the night and actually get to experience one of them. We chose an Earthship for a lot of reasons. Obviously, the recyclable materials that are used and no air conditioning and no heating. Well, that sounds fun. Let's, less money or input for those kinds of things, the better. So I did a lot of research on Earthships, and I found just as much bad things as good things. There's a lot of good stuff out there, And it's a really good selling point, and it's a really good home. They do function as designed. So there's no problem there. What we decided to do is give it a twist, more of a modern day twist. We talked about a lot of things. You can switch to the next slide, Tim. I mean, we've all talked about everything already, you know, work and help and longevity and all these things, and it applies to us, and we've been very much well dealing with all of that. But we thought about it, and we looked at everything about an Earthship, the tires, the recycled water. And when we originally approached Cochise County with it, I had, there's been so much bad information about tires. And so I did a little research, and I pulled 3 independent studies from 3 different universities about tires. Because I, like a lot of people, like the tires. Come to find out, tires are not bad as long as they're entombed. And one of the studies that I gave the county was a new landfill. I forget which state it was, but they shredded up these tires, and they put like 2 feet of shredded tires in the bottom of this brand new landfill. And what they found out was it kept everything from bleaching into the soil. So you basically put a rubber mat in the bottom like you would a pond, but they use tires, they shredded them, and they, you know, line the bottom first. So when you entomb a tire, encase it, take the oxygen, air, you know, light off of it, it's fine. But when you take crushed tires and shredded tires and you make rubber floor mats for playgrounds and those kinds of things, that's when it becomes toxic. Back to the tires. After a lot of consideration and thinking, and it was pretty much Miranda and I building this house. Miranda took the time to figure out how long it would take to pound pound 1 tire, and how long it would take 2 people to pound 2,500 tires. Very quickly, that was an option that wasn't on the table anymore. But we wanted to do a different type of building and do it a different way. So we sold the county on the tires. We solved their health problem, their mosquito problem. We took care of all that for them, and they were on board with it. Well, after we got the home started, or after we had talked to the county, we decided we were going to change those tires to concrete block. So our wall now is, and I don't even know where this thing is. Where's the pointer on this?
Why did the other way?
Oh, the pointer part. For the laser pointer? Okay. So here you can see the tires, right? All the way around. And then there's a row of tires here. What we've done, we called Mike Reynolds back, talked to him on the phone a second time. And I had asked him, I said, is there any other option to build these homes as designed other than tires? And he said concrete. You can do it out of cinder block. You can do it out of solid concrete, but you cannot do it out of ICF or any sort of insulated material, because now you won't have your heat, your transfer, your thermal, if we were to put an ICF block in here and fill it with concrete, now I've got insulation on both sides, and that defeats the purpose. Because what we're looking for is all this earth mass right here, is what we're looking for. So he said concrete, and that's what we did. And I'll get to some pictures. Our home is about 25% complete, so there's not a whole lot to see of what's going on. But before I get to that, I want to show you a couple of things. This little area right here, and this little area right here. This one's in the bathroom, and this one's in the kitchen. Those are grease traps inside your house. Okay. Yeah, pass. I don't want to clean grease traps in my own house, so pass. And so this, the first item was the block. It's all solid concrete. We have a bond beam on the top. It's actually built 10% over code, so the block wall shouldn't be going anywhere. And the next thing we did is we removed these grease traps. And the reason why those are there is because this is the biocell here that he's talking about. And the way he builds his homes, the second use water is the gray water. And so your showers, your bathtub, only kitchen sinks are black water, by the way. So your showers and your bathroom sinks, that water runs through a whole nother set of plumbing. And it comes in at one end of the greenhouse here. And however you want to design it, it could be either end. So your gray water comes in here, and then it is allowed to percolate through all of this grow media. Then it hits another tank that's in the ground. And then from there, when you flush a toilet, a DC pump comes on, and then it refills your toilet. It's a really great idea for a second use of water. Again, I don't want those kind of maintenance issues or smells or anything in the house. So what we've done is we kind of call this a modern day Earthship or hybrid Earthship, in that we installed a full up-to-date septic system with a tank and leach fields. It's got regular running plumbing and toilets and stuff like that. So when guests come over, there's nothing out of the ordinary. You know, it just keeps it simpler, and it keeps the maintenance down. One of the other things we're going to do here with this biocell is you have to take a backhoe, and this is pretty deep and it's angled to one end. And that's how you get the water to perk through it. We can't do that where we live. This section right here, which we didn't figure out until later, this is all rock. I can't dig here. It just falls in. So what we're going to do is we're going to do a wicking bed setup. It's a little easier to maintain. I don't have to dig a big hole across the front of the house. So that's how we're going to do that. A couple other things that we've changed is height of the ceiling. You can go ahead and switch, or I can do it here, right? Am I going the right way? Nope. Okay. As usual, we always start with a site, lay it out, and figure out where the septic's going to go and all that good jazz. There you go. There's some form work going in. I had to do this in stages. Everyone in the community is awesome, and we've had people pitch in. We've called them up. We've had 15 guys at our place, and it's just been amazing. Everyone's been amazing. But I've had to build this house a little bit out of sequence, and so right here you can see that the greenhouse foundation is not in yet. I took all the engineer drawings and I added 10% to the stamped engineer drawings. So this is 20% over what the engineer said it should be. For full disclosure, this is my first attempt at this type of structure, and I didn't want to have any problems. So I kind of went overboard a little bit. We did do some things to save some money. I mean, there's some things with this house like insulation. There are a few things, concrete, very expensive. Although hiring a bunch of people to come over and pound tires at $25 an hour is not exactly cheap either. So I think that ended up being a wash as far as what we paid in concrete versus what we would have had to pay for all that labor. And it, 2,500 tires is a lot of tires to pound. Our house is called the global model. It's one of several models he does now. In fact, he's doing 2-story Earthships. He's doing 2-car garages with them, 3 bedrooms, 3 baths. He's really evolved what he's doing here, and he has made some upgraded modern changes. There are a few things that he does not do anymore, for obvious reasons. So what we decided to do here, as you can see here, this is not a monolithic pour. This is in stages. This is a foundation pour with what's called a floating slab on the inside. Also, before I get back to the slab, this foundation has what's called a lower bond beam, a lower concrete bond beam. And what that is when we set this first row of block in, it's set into the concrete of the foundation. This block is part of this foundation now. There's no mortar under here. They're literally set in a 1/2 inch into the concrete. And then we poured them halfway at the time. So this lower bond beam all the way around this house is locked to the foundation and the first row, which we also did again at the top row. We did, here's the greenhouse footing. I also put in more rebar than required in 5/8 versus 1/2 inch. Again, I just didn't want to have any issues, and I've gotten some really interesting comments for this build too. Pretty fun. And here you can see the modern day, the septic system plumbing, and you know, it's coming together. Also, this is a dry stack system because it was mostly Miranda and I and a friend here and there. And I have no block laying experience, but I do now. This is called a dry stack method. And what we do is we dry stack the blocks 3 rows high. And then we come back and we fill all the voids with concrete, and we vibrate that concrete in. So there's no voids in any of the concrete. And then at the same time, while you're vibrating the concrete, the cream comes out and it gets between the blocks and basically glues the blocks together. The other reason why I did the dry stack method is, you know, all of us have said stories about the weather, and just all this stuff comes up. Life, weather, blah, 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 blah. And I wanted to be able to do a project where I could stop. And I could come back 3 weeks later and take off, and I wouldn't have any damage or any problems with the weather. And it worked out great. Also, the 3 little pigs, you know, building your home out of concrete is a pretty good way to go. Considering our south face, at the time, right now, there's nothing in front. We have no windbreak up front, and we can literally have 60, 70 mile gusts hit the front of this house right now. So we have trees planted, other things, courtyard's going to go in. So we should have protection on the front of it. Okay, here we go. One of the other things that we did, these are the cooling tubes. Now, in our original design, that called for a 10 to 15 inch diameter tube. I went to an 18-inch diameter tube because I know I have to change this air over inside the structure every hour. And one of the problems these homes have is a ventilation problem, air circulation problems, mold problems. So I tried to give it as much thought as I could in that the ceiling height inside the house, I added another 12 inches. So now it's 9 feet, 6 inches. And I'll get to the slide in a minute. I've done some things to the roof design. I'm going to incorporate full ventilation in the attic space and stuff like that. So this is where the cool air comes into the house, and then it will escape up through the greenhouse through a series of transoms, windows that you can adjust and open. This here, I'll get to the next one. You can see it, probably see it better. There we go. Here's another picture of it. I built concrete lintels. They're full of rebar. And then I used the concrete, it's all vibrated. And, you know, the culvert tube, it's got the ridges in it. So now the concrete is locked into those ridges. That tube's probably not ever going to come out of there. Yeah. So that was a thing we figured out right away. Here is the floating slab. It's kind of, that's a really big picture. Underneath this slab, earth homes are great, and they do what they will do with the earth mass. But when I did some looking into it, come to find out that the earth can be a bad thing, in that the wintertime, the sun's going to come through the building, through the greenhouse. And this year on the 21st, our sunlight made it all the way into the house, about 2/3 of the way into the house, and touching and heating all of this concrete. So what I did underneath this floating slab is I put 2 inches of rigid insulation. It's like an R12, I think it was. And the reason why I did that, and you want to do it with radiant floor heating too, because now the earth underneath this slab turns into a heat sink. If I get this warm, whoops, you know, during the winter, and it heats it all up without any sort of insulative barrier between that concrete and the earth underneath it, the earth would suck all the hot heat out of the concrete, and then it wouldn't do anything for us in the wintertime as far as releasing heat. So it's been insulated underneath for that. It's another picture of it coming together. I used these batter boards, and I learned this trick from an old block mason. And if you want to keep your block wall straight and plumb and square, you install these. It's the only way to do it. Now you can run your strings across the back, put your marks on there, raise your string up every mark, bam, 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 and just go. It's amazing. I was going to do this all by hand. And so that's a good little piece of handy information. If you take the time to put these batter boards in your corners, your block wall will go straight up every time. Let's see here. Yeah, here's a picture of the bond beam on the top. And one of the ways that we did save a few dollars, and we did this in every place we could, is they actually sell a bond beam block. You can buy the bond beam block. A little bit more than a regular block. So what we did is I just took an 8-inch diamond stone wheel, and we cut the centers out of the cinder blocks. I didn't have to buy special blocks. I didn't have to figure out how many I had. We just cut the bond beam and built it right on site. It was a little bit more work, but saved a little bit of money. Here's the tubes coming out again. We're going to add 10 more feet to the backs of these. And another thing that we changed was in the global model, or in his newer models, the water cisterns are buried on the east and west side of the house. Our model has the tanks back here buried under soil. And one of the things we didn't want to do either was maintenance, right? And you get older, and you know, you just don't want to be doing these things down the road. And you don't want to bring a backhoe in to dig up a cistern so you can make a repair. So one of the changes we made is we're going to have 4 tanks across the back here. This is a 2.5% grade. So all I got to do is put the tanks in row, and they'll gravity feed by themselves. They'll just go on down the road. This will, by doing that, this gets me access to the tanks at any time I want to do repairs or those kinds of things. So that's another change we made. Here's the greenhouse knee wall going up. It's 2 feet high. And just imagine this all tires. You know, for all intents and purposes, this house will function. It's being built the way it's designed. We've just changed a few things like block and some minor stuff. Here we go. Here we're starting to put the load bearing beam in. This was interesting. This beam that we built was not necessary. It's a bit too much. The reason being is in our original plans we purchased from Mike Reynolds, we were on the phone with him and we wanted to do a Vega style ceiling with the 12-inch logs. So he sent us blueprints for the 12-inch logs, and this is the load bearing beam for those 12-inch logs. But after checking pricing and shipping on those, and we needed 33 of them, yeah, that's $600 a piece, was a bit out of the budget. What's that? Oh, yeah. So just a couple more pictures. Here it is coming together with a roof on it. The picture of the back, and then all of this you see here gets buried in soil all the way up to this line. So that's about 10 feet there. And then it comes out 30 feet this way and about 15 feet this way with the soil. It also gets a rubber membrane or a curtain around the back. So it has a single piece vapor barrier, water barrier. Trusses are up. Got all the guys together. They came over and we had all those trusses up in 45 minutes. You know, guys are amazing. Everybody here is just amazing. Picture of the inside. This is second bedroom. You can kind of get a glimpse of the view. We had all these trusses made as part of my design. There's going to be ventilation that takes air from inside and takes it completely out. So we're going to put some systems in to actually keep the air fresher. This is about where we're at right now. I got some temporary vapor barrier over some of the big pieces of lumber. Then the greenhouse roof comes off here, and then it will go down to the greenhouse wall. So there's 6 feet of glass in the front of the house. And the only thing you're really going to see are just the windows and then the end pieces that are stuccoed and curve around the side. I think that's it. Starting to lay the walls out there. Yeah, another picture there, getting some walls going up. And that is it. Any questions? One subject. So my partner and I, Miranda, we moved out here 4 years ago. We bought property and just love it. And we started a market garden farm. We love to plant and do permaculture and those things. And so along with everything else that we do, it's been a little difficult to stay focused on the house a little bit. So it's taking a little bit longer than anticipated, but we talked about that today. That's how it works. So yes, we have a market garden farm, and we brought some food today, and we usually up in Portal every Saturday. And just, yeah, having a good time and enjoy everybody. And we're really the glass. Oh, good question. Phil from Alpha Glass. He got our glass for us and delivered them. Awesome. And we're going to get some doors from him, the exterior doors. And who else did we use? Phil over here, the glass, Alpha Glass. Some of us here may know Scott Stamer. Scott Stamer was the one that helped me start this foundation. And 2 days later, I get a phone call. He was actually going to help me do all this block work. So miss him. Donations, everybody around the valley, it's just been great. They've given us logs and just all kinds of stuff towards the project. We've got glass bottles and collection of all the goodies and stuff. And so it's been exciting. It's a fun journey. And, you know, with any house building project, you have all those frustrations and goes without saying, but we're enjoying it and I'm having a really good time. And solving some of these problems that these homes have. And again, Mike Reynolds made a claim many years ago, a blatant claim. And he says that these homes stay 68 degrees year round with no air conditioning and no heating. Well, that got up to different sections of the county, and the county's like, no. So they brought in an independent group to set up in these homes and actually see what the year-round temperature is. Well, he was wrong. It's not 68. It's 72 to 73 degrees year-round. Yeah. And so, like I said, we're building this as designed. We have the blueprints and everything. Just making some subtle changes. And I've sliced this two ways. I've sliced it with tires and bottles and cans and all this stuff. And I've sliced it the way we're doing it. And it's about the same money. It really is about the same money. This is also a home that unless you've got this stuff piled up and you've got a big family and lots of friends that don't mind swinging a sledgehammer all day long, they're expensive to build. I've ran the numbers. It doesn't matter. These are probably, because they're fully custom and they have to be built in a certain procedural way, they're just as expensive as anything else out there. Our budget's broke already. It's broke. But it will be cool. Now, there's no heat. There's no radiant floor heat. We opted out. We did our research on that. We opted out. We have no plans on selling it, any of that. So we don't care about any of that on the back end. I was going to say Cochise County. That's right. So we cleared all this with the county. County had two problems. One, where's the heat source? And two, where are the windows in the bedrooms? And I said, well, the windows in the bedrooms almost defeats the purpose. And he had a problem with the fire egress. So we sat down with him in Benson, showed him our plans, and we worked it all right there. I said, well, what if I move the doors in front of the bedrooms and I get below the 10-foot maximum of egress to the door and I make all the doors open out in the direction of egress? It'd be a little weird to get used to opening your door this way to walk in, but he liked it. All doors lead to egress within 10 feet. And so that's how we got this through the county. We just changed it up, you know. So our original plans are nothing other than the typical shape. Our house is completely different than the model we bought. So, more question? Thank you.